Hi, I'm Therese, and today we're going to build Project 3 from the project book, the Lavometer. The Lavometer is a device that can measure the temperature of your skin and show it on different LEDs as an output. Until now, we've been working with digital pins, sending values that are either high or low to turn LEDs on and off. But in this project, we're going to use analog pins to send a wider range of values, more exactly from 0 to 1023. The values are represented by the voltage that is sent and measured in the circuit, where 0 volt represents the value 0 and 5 volt represents 1023. All voltages in between are equally mapped between those values. In this project, we're going to use the temperature sensor to measure the temperatures of our skin. It will send different voltage outputs depending on the temperature that it receives. But before using it, we need to know a little more about it. Let's take a look at the datasheets. If you visit the link on page 49, you will get to the store page, where if you click on tech specs, you can find the datasheet for each component. Here's the one for the temperature sensor. It says here that it can measure temperatures between -40 to +125 degrees Celsius. It also says that the voltage output changes proportionally to the temperature with 10 millivolts per 1 degree Celsius, ranging between 0.1 to 2 volts. This means that -40 degrees corresponds to 0.1 volts and -39 to 0.11, and so on. This is important to remember later when we write our code. If we take a closer look at the sensor, we see that it has 3 legs. 2 legs on the sides will be used to connect the sensor to 5 volts and ground, while the middle leg will be used to communicate the temperature with the board. If you're having issues with differentiating the temperature sensor from the transistor, you can read on the component that it has 3 letters T and P. That is your temperature sensor. Now let's start creating our circuits. I have already connected the power and ground wires to the power and ground pins, so we have power and ground on these lines on the breadboard. Now I will take the temperature sensor and note that it has a flat edge on one side. It's important to find this side so we know which leg goes to where. I'm gonna place 3 legs on 3 different rows with the flat edge facing left. I'm gonna connect the top leg to power and the bottom leg to ground. Now we have one leg to power and the other to ground. The middle leg needs to be connected to analog pin 0. There, now we have the temperature sensor all connected. Now I'm gonna connect the 3 LEDs in the same way as we did in our previous projects. So I need to make sure that the long leg is facing the power side and the short leg the ground side. There, now we're all set. Open the example sketch named PO3 Lavometer. Starting from page 46 in the projects book, you will find a detailed explanation of the code. But I will also give you some extra tips here. A new element in this project is that we're using the serial monitor. The serial monitor is a way for us to see the status of a project by printing values from our components to be shown on a window inside our computers. For example, the temperature sensed from our temperature sensor. In order to use serial communication, we need to initialize the serial port in our sketch. In the setup, we write serial.begin to open a serial connection. Make sure that you use the same baud rate in the sketch and in the serial monitor. Now you can upload the sketch to your board. After it has finished uploading, you can click on the magnifying glass to open the serial monitor. Note that you can only do this after you have uploaded your sketch to the board. Now you can see the values printed on your computer screen. You can also see the LED's lighting change based on the temperature. If you happen to face the issue that all of your LEDs are on already from the beginning when you upload the code, it's probably because the baseline temperature is set too low. It's initially set to 20 degrees, But different homes have different environments, and the baseline needs to be at least as high as your indoor temperature at home. You can use the serial monitor to measure the temperature in your home when not touching the sensor. This temperature would be your ideal baseline value. If you find it difficult to read the values from the serial monitor because they are printed too fast, try to change the value of the delay. Start with 100 and increase if needed. Lastly, you can also try to modify the values for the LEDs to make them light for higher or lower temperatures by modifying the if-else statement. This device can be a fun way of testing compatibility between two people based on their body temperature, but can also be used in a lot of different ways. How would you use it? Share your ideas on social media using #ArduinoAtHome. See you next week. Bye!